Welcome to class. This is part of the topic we started under redox reaction. Gradually, we are getting close to the end of the topic. After calculation of oxidation number today, our next class is going to be how to balance redox equation. We're going to take our time, to show you how redox equation can be balanced. Today, we want to look at how we can calculate or find out the oxidation number of an element in a compound, or oxidation number in a neutral form. Oxidation number of an element that is in a neutral form, that is not actually combined with other elements. Okay? So, what is this oxidation number all about? What is this oxidation number? What is this oxidation number? In a simple term, or without using words that may confuse you, in a simple term or in a simpler form, see oxidation number as that number which an element will gain or lose in order to do what? Attain duplet or octet state. And I said this is the number assigned to an element when there is either loss or gain of electron. And I think this is the basic. Yes. The number assigned to an element when it loses electron, and the number assigned to an element when it gains an electron. I think from here we can now continue looking at what oxidation number is in their various form. For us to explore, or for us to get this, for us to understand this, we need to look at the rules in working out oxidation number. Rules in working out oxidation number. There are rules. This set of rules will help us understand what oxidation number is and how we can calculate oxidation number. Now, rule number one states, when you have a neutral atom which is in a free state, an element that has not reacted with any other element, an element that is still in an uncombined form, it has not ionized, it has not lost, it has not gained any electron. It says, rule number one states that the oxidation number of that particular element is 0. Is what? 0. This is a JAM and YA question. Yes, you have a neutral atom, and such atom is yet to undergo element. Such element or such atom of the element is yet to enter into chemical reaction. Right? Okay, if you encounter such element, its oxidation number is 0. How do you know an element that is in a neutral form, element that is in uncombined state? How do you know? Such element is just written with its symbol. Okay, I have calcium. This is calcium, Ca. There is nothing plus or minus here. It shows that the element is still on its own. No reaction has taken place. It is still in an uncombined form. So, its oxidation number is what? 0. Remember what we are doing? We are calculating oxidation number. How to calculate oxidation number? How to calculate oxidation number? How to calculate oxidation number. How to calculate oxidation number. How to calculate oxidation number. Well, taking it one after the other, considering a set of rules that are being mapped out that you must follow to do justice to this. An element or atom of an element is neutral. It has not reacted. Its oxidation number is 0. So if I have potassium, what is the symbol of potassium? The symbol of potassium is K. It has not reacted with anything. its oxidation number is 0. Its oxidation number is 0. Its oxidation number is 0. Okay? That is the first rule. Now let's look at the next rule. Let's look at the next one. That is rule number 1. Let's look at rule number 2. Let's look at rule number 2. Rule number 2 says, this is a rule that takes care of charged atom. Are you seeing it? We are coming from a neutral atom. Atom that is still an uncombined form. Atom that has not reacted. That is rule number 1. We've just entered into rule number 2. What does rule number 2 state? You now have a charged atom. An atom which has lost electron or gained electron. What becomes its oxidation number? Looking at the slide, it says the oxidation state of a charged atom, in bracket I have a simple ion. Yes, a charged atom simply means what? A simple ion. When we define ion as electrically charged what? Atom, right? And when that happens, we produce ion which are positive and what? Negative. So, the oxidation state of a charged atom is the same as the charge on the ion. Is the same as the charge on the ion. This has a lot to do with the gain and loss of electron. Okay. Now, for you to be able to do this, it is important you know those elements that have more capacity to lose their atomos shell electron, right? And those that have the capacity to do what? Gain electron. Because if you do it the other way around, I mean, give those that you're supposed to gain electron and you now assume they are losing electron, you will be assigning a wrong oxidation number to that particular element. That is the truth. Now, how do you know that? You must take your mind back to your elementary chemistry where we have what is called the electronic configuration. I mean, where electrons are distributed in their shares. Where electrons are distributed in their shares. And the shares K, L, M, N, and so on from the alphabet have been chosen, right? It was agreed that the K should take a maximum of 2 electrons, then this 8, this 18, this 32, and so on and so forth. But because most elements actually want to attain octet state of stability, right? In the first 20 elements, we'll consider the L, M share, and N to take 8 each. And the only element that has attained this level that has any of these atomos share completely filled is unreactive, cannot react. This is what we know before now. Okay? So in summary, I want to also remind you how you know those elements that will either lose electron or those that will gain electron. When you have this electronic configuration written, check the last shell. If the last shell contains or has less than 4 electrons, that means the element will lose such electron so that the next shell will become complete, which will now serve as the outermost shell. You remember? Yes. The reason is this. That last shell electron that contains 1 is looking for more 7 electrons to make it up to 8, which is octet level. But to that particular element, if I should lose 1 electron and the shell follows it in such a way that the next shell that comes becomes the outermost shell, which is complete, automatically the element moves on that direction. Whether loss of electron or gain of electron, energy is utilized. So each element is actually looking for a way to do what? Spend little amount of energy in the course of chemical what? Reaction. In that case, I have the following elements. I have the following elements. I have lithium, I have sodium, I have calcium, I have chlorine, I have oxygen. So let us see. I'm writing the shares now. K, L, M, N shell. These are the shares I have. What is the atomic number of lithium? Lithium is atomic number 3. Sodium is atomic number 11. Right? Calcium is atomic number what? 20. Chlorine 17. Oxygen 8. Now, let's distribute the electrons. For K will not take more than 2. I have 2 electrons here coming from here. How many are remaining? I have 1 left, so that 1 will be here. Look at it. How many electrons do you think we have in the last shell for lithium? Is what? 1. Is 1. So what happens? It shows that lithium, during chemical reaction, or when it ionizes, or when it becomes a charged atom, that is going to lose what? 1 electron. In that case, how do we write the charged form of lithium? You write the symbol, which is Li. How many electrons did it lose? It will lose 1 instead of gaining 7 to make here 8. So losing 1 attracts positive sign. That is +1, which we write as what? Plus. The atomic number remains what? 3, because the proton number does not change. In this case, this has become a charged atom. What is the charge carried by this particular particle? The charge is what? +1. Therefore, the oxidation number is what? +1. That is what we meant by saying that the oxidation state of a charged atom, you can see, lithium has become a charged atom by losing 1 electron. So what is the charge? +1. And therefore, the oxidation number is +1. Is +1. Thank you. Now, look at the next element, sodium, atomic number 11. I have 281. Again, 281. It's still losing 1 electron. If it is reacting now, it will lose this 1 electron. Instead of gaining what? Instead of gaining what? Up to 7 to make here 8. So it will simply lose this one, right? And when it loses this one, the shell follows it in such a way that the next shell is now complete. That is the essence of that loss or gain of electron. Elements do that in order to attain these 2 states of stabilities. You should be aware of this. They do this. Most elements that have already gotten to that level, they don't bother reacting. Bring substances, elements around them, they remain inert. They are unreactive. So these ones that their atom shell electron are not yet complete. They are always eager to undergo chemical reaction. So in that case, this one loses electron so that the next shell becomes complete. How many electrons did it lose? It actually lost 1 electron. That means when you write the symbol sodium, which is Na, atomic number 11, it has lost 1 electron. That means the oxidation number is what? +1. +1. If you follow the same pattern, we'll go to calcium. Calcium will do what? We'll lose how many electrons? Let us distribute the electrons in their shells. Let us distribute the electrons in their shells. Let us distribute the electrons in their shells. I have calcium. Calcium is how many now? Atomic number 20. Let's go now. So I have 2. The next one takes what? 8. As I said, for the sake of this octet level and considering the first 20 elements, after decay, the other ones are now looking for 8, 8. So if I give 8 to L, I have consumed how many electrons out of 20? That is 10. So I will put the next 8 here, right? And the remaining 2. What is happening here? How many electrons do we have at the last shell of calcium? That is 2. So calcium will always find it very difficult to look for 6 electrons than to do what? Lose 2. So it will actually lose 2 electrons. And once it loses that 2 electrons during chemical reaction, it becomes 2+, which is now a charged atom. Charged atom. What is the charge? +2. And therefore, oxidation number is +2. Is +2. The next 2 elements I would like us to look at are chlorine and the oxygen. Chlorine and the oxygen. Chlorine and oxygen. Do you still remember the atomic number of chlorine? Yes. You still remember? That is 17. Chlorine is atomic number 17. Now, follow me. Let us distribute the electrons. I have 2. I have 8. Remaining how many? 7. This one is not like the ones we have been doing. Look at this. 7 electrons at the last shell. The last shell contains 7 electrons. It's looking for 1. 1 electron to make here 8, or it loses the 7. Where do you expect this element to look for to get energy to gather more what? Or losing 7 electrons. You expect it to lose 7 electrons. Why it can just spend little energy to gain 1? So it's going to gain 1. 1 electron will be gained by this. And once it gains 1 electron, it's gaining. Gaining is negative. So minus 1 is gaining actually 1. That is minus 1. That shows that the charge is what? Chloride ion. The charge is minus 1. The oxidation number is minus 1. Atomic number, which is the proton number, remains the same. Okay. What of that of the oxygen? Oxygen is atomic number 8. Is oxygen 8? Let's go. I have 2 in the K shell and I have 6. How many electrons do we have in the last shell? 6. More than 4. Once the last shell contains more than 4 electrons, once it contains more than 4 electrons, you should expect that element to gain than to lose. So this one is going to gain how many? Check it. Well, we want to make this L shell to have 8 electrons. So how many electrons do you think it needs? It needs how many? 2 more electrons. So this will require 2 more electrons. So once it gains these 2 electrons, here becomes 8. And that means the element has become a charged atom. Charged atom is enhanced by either gain or loss of electron. What is this charged atom? It's commonly called ion. That is what? Ion. So as it gains 2 electrons, oxygen becomes O2 minus. Still maintaining the proton number, which is what? 8. Therefore, what is the oxidation number? Oxidation number is minus what? 2. Oxidation number is minus 2. Okay. We have seen that of the minus 1. We have seen that of minus 2. Can we look at that of the minus 3? Which element do you think that can gain 3 electrons? That is nitrogen. Nitrogen is atomic number 7. When we distribute the electrons, the K shell takes 2. The L shell takes how many? Remaining 5. So you can see the last shell is still having more than what? 4 electrons at the outermost shell. So it will be very easy for this element to gain 3 electrons and then to lose what? The whole of the 5. So as it gains 3 electrons, remember the aim, do not forget. The aim is to make sure the outermost shell is completed with 8 electrons, which every element that have not attained that level is looking for. So they do this by loss or gain of electrons. So this one is gaining 3. As it gains 3, nitrogen atom will now cease from being ordinary neutral atom and becomes what? A charged atom, which is having a charge of what? 3 what? Plus. 3 what? Plus. Remember, proton number remains the same. So what is the oxidation number? Oxidation number, according to what we have on the slide, the oxidation number is what? The same as the charge on the ion. So what's the charge on the ion? Plus 3. So the oxidation number is what? Plus 3. This is the second rule. This is the second rule. So let's quickly look at the third rule. Let us quickly look at the third rule. The third rule. The third rule, I want you to pay attention to the third rule. That is rule number 3. Rule number 3. Let us look at rule number 3. Rule number 3. Rule number 3. This rule deals with compound ions. That is compound that carry charges. The one we just finished has to do with an element that carry charges. Elements that carry charges. You see an element, and the element is actually having plus or minus on top. Minus 1, what does it mean? It gained 1 electron. Plus 1, what does it mean? The element lost 1 electron. Minus 2, what does that mean? The element actually gained 2 electrons. And plus 2, what does that mean? The element actually lost 2 electrons. Plus 3, the element lost 3 electrons. And the minus 3, the element gained electron. Just an element. Just an element is not a compound. Rule number 3 is trying to address that which is a compound. Do not forget what a compound is. A compound does not just have one element. A compound is best defined as chemically combined combination of what? Chemically combination of what? Two or more what? Elements. That means any substance you see to be a compound is not actually bearing an element. You see 2, 3 elements and so on and so forth. But they are chemically combined. Look at the slide there. You will see I have SO4. SO4 means that sulfur is actually in combination chemically with what? Oxygen. Right? Yes, but there's something about that compound. It's not just sulfur. It's not just oxygen. But they are together. What does that show? It shows that that is a compound. But look at that compound. That compound is carrying 2 minus. So it is not a neutral compound. It is called what? A compound what? Ion. If you don't call it a compound ion, you can also call it a polyatomic ion. If you don't call it polyatomic ion, you can simply call it a radical. You can simply call it radical. So when you see compounds carrying charge, when you see compounds carrying charge, they are called radicals. They are called compound ions. They are called polyatomic ions. How do we define these compounds that carry charges? Now listen, before I throw more light to this, how to apply the calculation, you need to know the meaning of these compound ions called radicals. They are group of atoms. You see, it's not just an element. It's not just an atom. But they are what? Group of what? Atoms. Behaving as one. Behaving as unity. As you see SO4 there, SO4 behave as one. SO4, wherever it's going into, any reaction it wants to undergo, any reaction SO4 is actually trying to take part in, the SO4 will move as one. Sulfur will not be moving differently. Oxygen, 4 atoms also move. No, they behave as one. And they have a charge which now keeps their what? Identity. So what does that mean? A radical is a group of atoms, or radicals are a group of atoms behaving as a unity. That's how you put it. Behaving as unity. Possessing a charge which keeps their identity. When you see such thing, it's not just a compound, but a compound that carries what? A charge. How do we face this kind of compound? I mean, its oxidation number. The rule now says, add or sum the oxidation number of all the elements in that compound that make up that compound, and then equate it to what? To the charge it carries. What does that mean? I have sulfur, I have 4 atoms of oxygen, and all of them possess the charge 2 minus. So what it's trying to tell us is this: oxidation number of sulfur plus oxidation number of oxygen should give us equals to -2. Look at it here. Look at it on the slide. Say using the alphabet, using the sulfate ion radical, the rule states that oxidation number of sulfur plus oxidation number of oxygen is equals to -2. If we decide to calculate the oxidation number of sulfur, the calculation is as follows. Please, I want you to pay attention. Pay attention to this. Pay attention. Let us see how we can calculate the oxidation number of a particular element in that compound ion. I have SO4 2 minus. The rule says oxidation number of sulfur plus oxidation number of 4 atoms of what? 4 atoms of oxygen, 4 atoms of oxygen, 4 atoms of oxygen, right? Is equals to what? The charge they carry. What is the charge? Minus what? 2. How do we do this? First of all, identify the one you are asked to calculate its oxidation number. Assuming from this compound ion or this polyatomic ion, or this radical, you are expected to calculate the oxidation number of sulfur in this compound ion. What do you do? Just bring down the sulfur down. It will say sum. So I'm summing. I'm just adding all of them now. Plus, in as much as they did not ask me to calculate the oxidation number of oxygen, what do I do here? I will ask myself, oxygen on its own, when oxygen wants to react, how many electrons does it gain or lose? Of course, oxygen gains how many electrons? 2 electrons. So if oxygen should gain 2 electrons in this case, what is the charge? Minus what? 2. So you bring in the number of electrons that element will either lose or gain during chemical water reaction. That is what you write. In the position of a particular element, you are not asked to calculate its oxidation number. In that case, I am not asked to calculate oxidation number of oxygen. So I'm going to bring in the number of electrons it gains. How many? 2. Do not forget that gaining attracts negative. I have minus and I have 2. Where is this 2 coming from? This 2 is coming from that number it gains. Then how many atoms of oxygen do I have here? I have total of how many? 4. So I'm going to multiply that minus 2 it gains with 4. Because in this compound ion, the oxygen has 4 atoms. So after doing this, the rule says equate all of them to what? To the charge which the radical itself carries. So I have minus what? 2. This is now calculation. I am looking for sulfur. So I have sulfur. Plus minus is minus. 2 times 4 is 8. So I have equals to minus 2. If I should still keep sulfur at my left-hand side, already it has made itself subject of the formula. I have sulfur equals to minus 2. If minus 8 crosses sign of equality, it becomes plus what? 8. So S is equals to minus 2 plus 8 is equals to what? The answer becomes equals to what? Plus what? 6. So what does that show? What does that show? That shows that what? The oxidation number of sulfur in this compound is called what? Is what? Plus 6. You can see it there. You can see it. Yes. So if you should adopt this in terms of IUPAC nomenclature, you will agree with me that this is called tetraoxosulfate 6 ion. Tetraoxosulfate 6 ion. You see, the number I pronounce after the last element shows that it is that element, that last element, that has it as oxidation what? Number. Okay, that is the third rule. Now the last rule is rule that has to do with rule number 4. This one now is a compound, but the compound does not carry any charge. The compound is a neutral compound. A neutral compound. What happens to a neutral compound? What is a neutral compound? Neutral. No positive, no negative on top. It's just a neutral compound, right? It does not carry any charge. You must apply the same method we use in rule 3. But the only difference is this. After summing all the oxidation number of all the elements in that particular compound, since it does not carry any charge, equate it to 0. Equate all to 0. Look at it, the one I have on the slide. It says that of the sodium nitrate. That is sodium triosonitrate what? 5. That 5, we are going to calculate it here now. Okay? Now, we are looking at this. Look at that compound, NaNO3. There is no charge on top. It is just NaNO3. That is what we have there, right? So if you add all the oxidation numbers, sum all of them, equate it to what? 0. Now let's apply that method. Because for us to apply the method, we must be able to calculate the oxidation number of a particular element in the compound. Let's go by the calculation of oxidation number of this nitrogen. As I said before, for you to understand this, you will always be asked in exam to calculate the oxidation number of a particular element in that compound. So let me calculate the oxidation number of nitrogen in this compound. Let's go now. I'm looking for nitrogen, I'm not looking for sodium, I'm not looking for oxygen. So what do I do to those elements that I'm not looking for their oxidation number? I will bring in their oxidation number when they are alone and when they carry a charge, especially when they carry a charge. Sodium loses 1 electron. Loss of 1 electron attracts what? Positive. So this is the positive, and this is the one sodium loses. I'm talking about from the sharing of shares. This is 11. 11, it is going to be 2, 8, 1. The K share has 2, the L share has 8, and the M share has 1. So it will lose this 1 electron. That is plus 1. Then plus, I am looking for what? That of the nitrogen. That's what I'm looking for. So I will simply bring down the nitrogen. And then I will have plus, remember, sum. Look at what I have on the slide. It says, this means oxidation number of sodium plus oxidation number of nitrogen plus oxidation, of nitrogen plus oxidation number of oxygen is equals to 0. What does it say? The sum of the oxidation number in a neutral compound is 0. So I am summing now. I am gathering all of them together. Plus 1 plus N, which is nitrogen I'm looking for, plus oxygen. How many electrons does oxygen gain? Oxygen gains 2. Gaining attracts negative, and this is the 2 it gains. But in the particular compound we are using, oxygen is how many here? 3. It's triatomic. So I'm going to multiply the 2 by 3. And they equate all of them. It does not carry any charge. So it's being equated towards 0. This is now simple mathematics. So I have 1. Plus 1 is 1. Plus nitrogen I'm looking for. Plus minus is minus. 2 times 3 is 6. All is equals to 0. Making N subject of the formula. What do I have? Nitrogen becomes equals to plus 6, because definitely the minus 6 will cross sign of equality, and definitely the minus 6 becomes what? Plus 6. Plus 1 crossing sign of equality becomes minus 1. So therefore, the nitrogen is equals to plus what? 5. What does that show? The oxidation number of nitrogen in sodium nitrate is what? Plus 5. That helps us to pronounce or to call the IUPAC naming. Thank God in IUPAC naming, it is nitrogen that is being pronounced before the number you bring in. That number you bring in is the oxidation number of that nitrogen. So how do we pronounce this? This is sodium triazonitrate 5. Have you seen it? Sodium triazonitrate 5. Sodium triazonitrate 5. That does not mean you cannot calculate oxidation number of any other element in that compound. No, it doesn't mean that. We can calculate that of the sodium. We can. Okay, let's just do one more. Let's just round it up with that of sodium sulfate now. What is sodium sulfate? Sodium sulfate is N2SO4. Let us calculate that of the what? Sodium, and no longer sulfur in the middle. Okay, we are looking for this. Let's go now. Sodium we are looking for is what? Carrying 2 atoms. So it's going to be 2 multiplying sodium, which is 2N. We are still using the Na because that is what we are looking for, Na. Then plus sulfur we are not looking for now. We are going to bring in the number of electrons it gains. Sulfur is atomic number 16. 286, right? It's gaining 2 to make that 68. So gaining is negative, and this is 2 is gaining. Then plus, of course, we have been using oxygen. Oxygen gains 2, which is minus 2 times 4, because it has 4 atoms here. Equate everything here to 0 because the compound does not carry any charge. So I have 2Na plus minus is minus 2, plus minus is minus 8, all is equals to 0. So 2Na becomes minus 8, crossing sign of equality becomes positive 8, and minus 2 becomes positive 2. So my 2Na becomes equals to what? 10. So from here, what is my Na? My Na now is equals to what? 10 divided by 2, which is plus what? Plus what? 5. Plus what? 5. You can see the oxidation number of sodium in that compound called sodium sulfate or sodium tetraoxosulfate is plus 5. This is the last rule. You'll always be asked to do this in your external exam. I want to believe that so far we have done, will also go a long way to help out. Thank you. But before we round up, let us also look at 1 or 2 questions from our exam guide. Let us look at 1 or 2 questions. Probably the one that has to do with oxidation number. Let's go. Let's look at the one that has to do with oxidation number. Okay, look at it. Okay, do you want how many electrons? Okay. We're looking for the oxidation number. Now, say the oxidation number of sulfur in Fe2 bracket SO4 bracket 3 is dash. If you calculate this for sulfur, you are going to get that of 6. Quickly, let's do that. Quickly, let's do that. And with that, I want to believe the topic is well taken care of. I have Fe2 bracket SO4 bracket 3. I am looking for sulfur. I'm not looking for what? That of the what? Ion. I'm not looking for that of the ion. I'm not looking for that of the ion. So that is ion 3 tetraoxosulfate 6. So that means this is plus 3 times 2 plus sulfur, which is 3x, plus oxygen, which is minus 2 times 4. Then you have to multiply it with what? Times 3. Right? Can you see that? So what do I have here now? I have plus 6 plus 3x minus 2 times 4, 8. 8 times 3 is 24. Or is equals to what? 0. So what do I have? I have 3s is equals to 24 minus what? 6. Right? Which is equals to what? 24 minus 6 is 18. That means I have 3s equals to 18. If you make s subject to the formula, s becomes 18 divided by 3, which is equals to plus 6. So the answer there we have on the board there is plus 6, which is option B. Let's check. Option B. Let's now check the answer. Option B, we are correct. We are correct. That is fantastic. We are correct. We are correct. That is fantastic. We are correct. So look at it. Exactly. Look at it. Can you see the solution? How it's being solved? That is exactly the rule we have just applied. Thank you. Thank you. Thank you. I want you to explore. I want you to do more. I want you to study more so that this topic will be one of your best topics. As it comes out in the exam, make sure you attempt it. Thank you. Until I see you next.